Welcome, welcome. Welcome, welcome, welcome. We are going to be starting up really soon here. Hello, we're live. How are you guys? Hello. Thank you so much. Much love to you as well. How are you doing? I'm about to sit down with my water and we will do a bit of reading. I'm very hungry, so I think we will also eat. So I call this hungry black holes because I'm hungry and so can sometimes be black holes. Hello, Goldust. I see you. How are you? How are you doing, my love? Thank you for liking the live, my darlings. Thank you so much. I'm getting it started on the phone, the other phone here as well, so I can look at what we are seeing. Hello, everybody. Okay, I'll be right back. Let me grab my earrings. Forgot them. Sachi. Okay, fine. You can go. It's okay, Sachi. You can have a little fun. It's okay. Have fun, Sachi. It's not too cool today. Sachi's in a room that she is generally not allowed in because I keep that room closed, and I keep the heat off in that room, but it's actually less cold today, so it's fine. Hello, Dr. Soda. Okay, one more second. I need to grab my water. I grabbed my earrings. Oh, Sachi Mama is here. Hello, Sachi Mama. You can go play if you want. If today is not very cold. We don't have the heat on in that room. Mama's getting water, Sachi. Okay. I am coming to the chat, guys. How is everybody doing, my loves? How is everybody? Okay. Is anyone hungry? Because if not, you're about to be. We're probably gonna eat again tonight. Hello, Selectrovert. How are you? Let's see. I still have to do a little bit of hair setup. Oh my gosh. My hair got stuck. Oops. See, I have a knot. Ow, 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 ow. I have a knot in my hair, guys. Maybe I'll get it out as I read the comments. So, everybody, thank you so much and welcome, welcome, welcome. Welcome indeed. Welcome one and welcome all. Hello, 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 my darling friends. Can we get 10 likes? And indeed, we are here. We are alive. It's not a short. It's not a premiere. It is not a video. It is alive. We are alive and we are live. Thank you, God, and thank you, universe. Indeed, we will pray and thank the gods. And we will get started. And welcome indeed to my continents, South America, North America, Africa, Antarctica, Asia, Europe, where are you? Where are you? Where are you? Where are you? Australasia, the oceans. If you're in the middle of the ocean, we like you here. Please connect to the Wi-Fi's and find us alive. Find us in this live stream, please. Thank you so much. All of the oceans, all of the continents, all of the countries, New Zealand, Madagascar, South Africa, Boston, the city of Boston, where we do live in, all of the places and all of the countries and all of the cities. Please do join us live right here, right now. Your camera presence is vibey. Oh, thank you. Well, thank you so much. Thank you so much. And can we get 10 likes? Thank you. Thank you. Thank you. Thank you. You are guaranteed some physics discussions, some learning, some class, some class meeting or fun discussion in the form of 1 second, please. Sachi Mama is topsy-turvying a bowl of water. Okay, I think we'll just have to let it be. Sachi Mama, good job, Mama. Mama loves you. Good job, Sachi. Sorry about that. I do apologize for these kitty cat related interruptions. That is also guaranteed on the channel. We do present kitty cats. I am their mother, a feline mother, that is, as in I am human, but they're feline. Sometimes I am feline too, and quite feral actually. But in general, we present my face and kitty cats and discussions of physics, astronomy, astrophysics, and cosmology. I hope that many of you are here and that I will see many new and old faces. I will read the chat, the chit chat, the chatter in quite a little bit of time here in just a few minutes. Please do hang tight and continue hanging out with us. It would be most appreciated. I also made a goal for super chats. And of course, if you do a super chat, that comes to my attention a lot easier than the normal chats. Okay. So tonight we will actually cover the topic that we didn't quite get to last night, because we have these lives quite often, guys. It is quite often that we have this delightful opportunity, especially in the winter times. And so we will now do that now tonight. So this book that I have here, Death by Black Hole, we will be reading out of that and doing some discussion related to that. And also we will be taking your questions. Where's your babies? They're around. They're kitty cats. And so the gifts and super chats do come to my attention a lot easier than the normal chats. Yes, indeed. So Suji Mama is right here. Baji and Fuji are upstairs. You will probably end up seeing some kitty cats. They are often present during these lives, okay? So thank you so much, everybody, for being here. Can we get 10 likes? And I'm going to set up the live on my other machine as well. Ow. My hair is extremely a little bit knotted up in the back. So I am still a little bit in the process of managing that. And I will say that tonight's itinerary that I have thought of is that we will do some reading from the book. We will discuss the topic, and then I will look at the chat while I'm eating because I'm quite hungry, and I will be making the peanut butter and Nutella sandwiches that was a hit last time, but that also because that's what I have and that is what I am craving as well. Hello, Sergeant Dexter. Hello, Key One. Hello, Null. Hello, Selector Overt. Good job, Sachi. Good job. Hello, CHS. Sachi Mama is my daughter, not my mother. I am her mother. J Dub. Hello. Hello, J Dub 417. Oh my gosh, my half birthday twin. Hello, Kiwan. Hello, Siddharth. Hello. Selectrovert Nal Snookamui. Baji sounds like an Indian name. He is. He's an American kitty cat with an Indian name. Kiwan, hello. Dr. Soda, hello. Gold Dust, hello. Okay, I think I see everybody pretty much already. So thank you so much. Do you use whey protein? Why, yes, I do. I do own some whey protein. Oh, really, Sergeant? Oh, thank you so much. VPLOCC has sent a floating heart. Thank you so much for the gifts and the super chats and the comments and chat messages and the floating emojis going up. Really love to see it. Hello, VPLO. How are you doing? If you ever need help with your hair, you know I've been doing hair for 20 years as of this May, so always feel free to ask for any help. Oh, thank you. Oh, sorry, did I miss somebody? Phil Ye Bois. Hello, Phil Ye. I just have to make sure I'm not saying anything inappropriate. Oh my goodness, Tyson. Thank you so much. Phil Ye, how are you? Hey, over here, you missed me. I got you now, Phil Ye. Tyson Jays is here, one of my mods. Thank you so much, Tyson. This could be Neil deGrasse Tyson. We don't know, but thank you, Tyson, for being here. Null4961 is saying isolate or concentrate. Do you mean the whey protein? So I just have the whey protein powder. And I don't really mix it in the milk and drink it every day like I am supposed to. But I own it. I do have a big can of whey protein and it's partially been consumed and I have it. In fact, it's funny that you ask. Tomorrow I'm planning to go to the gym and taking some whey protein before I do that because probably I have not been eating enough protein as usual. Tyson, thank you so much. I didn't have a chance to heart or like the gift. When you if you do it again, I will make sure I catch it before it goes away. It was in the screen, then it went away. Sorry about that. I meant to like it and heart it. Phil Ye, hello. You can just call me Phil. Hola, hola, amigos. ¿Cómo estás, Acacio? How are you doing? How is Dominican Republic? How is Madagascar? We are saying hi to you. I am more Mike Tyson lol than Neil deGrasse Tyson. Yes, ma'am. Keep going, gym. Yes, so I do go to the gym more often probably than I take the whey protein, to be honest. The whey protein, I kind of forget. I'm not like a huge fan of the taste of it and like the consistency of it. Maybe I put in too much or something when I do take it. So for whatever reason, it always becomes this very coagulated drink with like chunks and whatnot. Oh, and I think the problem is that I don't have like a way to mix it like using a machine. I don't have one of those things. So it always ends up being sort of thick and I don't like the consistency of it. So I don't drink it very often, but I go to the gym more often than I do whey protein. But I do eat eggs. So in my defense, I know I'm supposed to eat more protein, but I do eat eggs regularly. So, and including today, I ate an egg. I hope that is a good thing. So now let me set up the live over here on the computer. Oh, and let me say, please do like, share, and subscribe. Like and subscribe. You're looking like newspaper. Yes, this dress does have that effect. It is a newspaper looking dress, isn't it? I like it. It's very soft and comfortable. There I said to please like and subscribe. Please do like, share, and subscribe, ladies and gents. And now we will go into the live monitor. Hello, Dad HF. When I go to the gym, I usually go to Tropical Smoothie after and get the chicken wrap and peanut butter chocolate smoothie with whey protein. It's a must. Oh, look at Tyson. Tyson is all ripped with huge muscles. Well, Tyson, I hope that you utilize your muscles to give us some likes, shares, and subscribes. And also virtually with your modding abilities. We're in good hands, guys. Acacio is saying, I think you are eating pretty good. You keep looking like a teenager. Oh, thank you, Acacio. Selectrovert says nice. Hello, Selectrovert. Okay, so let's see. Hopefully, can you see my, whatchamacall? The tags and things like that. Hopefully that is happening. Please do like, share, and subscribe. Okay, I think it's happening. I think it is happening. I don't know. Hopefully it's happening. Please do hang tight, guys, and thank you so much. I think, do you guys see a book? I just want to make sure that my links are working. Okay, maybe not. Maybe not. Thank you. Yes, please subscribe and like, everybody. I called the live Hungry Black Holes. Last night, this live stream actually became very lively towards the end, and we had a great time. We had a lot of surprise visitors and gifts and love, and we had a whole thing going on. So if you missed it, you might want to catch the end of the last night's live. It was quite a drama. It was quite a happening. Okay, let me share the live as well from my phone, because I'm not sure what is happening from the other device. Subscribe and like, chat. Yes, please. I'll tell my channel, get in here. Get in here. Thank you, Juan. I see your emojis. Oh, maybe I have to do something with stream settings. Thank you for the likes, guys. Can we get 10 likes? Thank you so very much. Juan says you're so beautiful. Well, nothing I can do about that, but can you like the live? Indeed. Not much I can do there, darling. I do look nice right now, don't I? Except for the pimple on my forehead. I have a gigantic pimple there, which is fine. Let's see. Customization. Okay. Save. Is the thingamawitch happening now? Is the thing happening with the thing? Do you see a book or not? Oh, now you do. I see it from my phone, other phone. Okay. I think the thingy thing with my link is happening. Good. Thank you so much, everybody, for your patience and for 10 likes. I really appreciate it. We will now get started. I think what I'll do is I pretty much caught up with the chat already. If I missed you, then please do say something in the chat. And then what I'll do for the itinerary of tonight is that I will read from the book and we will do a little discussion of the black holes, okay? That I promised last night and didn't get to. So we'll do that. And if you fall asleep, no worries. This is a sleep ASMR of some kind. So no worries at all. Keep it going, keep the live moving and playing in the background as you are working, sleeping, whatever. And if you see this later on, please do play it as a video. It should be posted under the live tab of the channel as usual. And give us a comment, leave us a comment. Thank you so much. Let me get it going and get started with the reading, and then I'll go back to the chat. Okay, I see my own chat message there. So I think I'm pretty much caught up as it is, and I will, after I do a little bit of reading, I will take a break to look at the chat again, and I will read off the top fans, and I will probably grab myself a sandwich, make myself a sandwich. Hello, Joe. Hello, Selectrovert. Well, thank you so much for all the nice, kind comments. Can you do gifts and super chats to help me meet my goal as well? Thank you so much. Like and sub. So, I think I've done the do of all the settings. Now I will get started after I sip a water. It's rather oddly peaceful right now, isn't it? You should wait till there is more drama. Sometimes there is. And then there was a super chat duel happening last night between a lady and this other guy. And then the lady won. And she was pregnant. And we were supporting her and her first trimester, and we ate in her honor. And tonight we will do the same thing, except I'm really very hungry, so we will eat a sandwich again tonight. Okay, you texted me yesterday. Where? Here or on some other platform? So we will read from this book, indeed. This is called Death by Black Holes by Neil deGrasse Tyson. Hello, Phil. How do I become as smart as you? Oh, well, thank you so much. That is very kind of you to say. We will read from this book called Death by Black Hole by Neil deGrasse. And actually, we will read the chapter called Death by Black Hole, because this book has a lot of chapters. I will tell you how many chapters, if there's a contents page, there is. So there are 7 sections of this book and lots and lots of chapters, total of 42 chapters. And we will not be reading all of them, although I wish, because I'm sure they're great to read. But what we will do currently is we will go into this chapter called Death by Black Hole on page 283, and we will read it as a sleep ASMR for people. But if you are interested and if you have a question, please do put it in the chat. We will certainly look at it and discuss further as soon as I have a moment. So don't feel shy. Dominate the chat, okay? And keep it keeping on. Keep it keeping on. We have also read a bit of this book in the past, and it was very nice. I believe we read the chapter called Dust to Dust. It was quite emotional and psychologically pleasing. But now we will keep on going. Death by Black Hole. Hello, David. Hello, Sam T. Thank you for being here. Can you like the live and subscribe, everybody, and give us 20 likes, please? Without a doubt, Acacio! Oh my gosh, I just looked and then Acacio did a super chat. Oh, thank you so much, Acacio. Also, Suji Mama has ran all the way downstairs from upstairs and gone up to the exact highest point of the room here. Acacio, so much, as in thank you so much, Acacio. Let me heart and like it. Acacio 59, my friend from Dominican Republic, has done a super chat. How very kind of you indeed, Acacio. Thank you, Acacio. Joe Dirt sent an emoji. Phil says, do you have a PhD? I do, darling. Acacio says, in case I fall asleep. Oh, good job, Acacio. You should put the phone beside you and start to relax. Thank you so much, Acacio. Tonio is here. What's the topic of this live stream? It's black holes, darling. We're just about to start reading, so you're here at a good time. And Acacio did a super chat, so I was thanking him. Thank you so much. Hello, Miguel. Without a doubt, the most spectacular way to die in space is to fall into a black hole. Where else in the universe can you lose your life by being ripped apart atom by atom? Black holes are regions of space where the gravity is so high that the fabric of space and time has curved back on itself, taking the exit doors with it. Another way to look at the dilemma, the speed required to escape a black hole is greater than the speed of light itself. As we saw back in section 3, light travels at exactly 299,792,458 meters per second. Sometimes we just say 3 times 10 to the 8 meters per second, but that's the more accurate. In a vacuum, and is the fastest stuff in the universe. So the speed of light is the fastest speed of anything in this universe, the speed of light in vacuum. And what the author is, of course, reminding us that even light cannot escape a black hole. Okay, such is the gravitational field of this black hole. Is very extreme gravitational field, and even light cannot escape. Okay, it bends space-time in such an extreme way. As we saw, so if light cannot escape, then neither can you, which is why, of course, we call these things black holes. So if you fall in, actually, we had a discussion at one point. It really depends on the black hole, whether how much pain you will feel as you're falling in. Okay, now let's see what Neil deGrasse has to say on the topic. So I won't get into that too much, but we can certainly come back to it. Somebody's asking, what is a black hole? So the black hole is a type of stellar remnant. When a star dies, the most massive ones will compress to a very extremely compact object under the gravitational collapse of the star. And that extremely compact object is a black hole. There are a few different options for a star to form once it's dead. So a few different stellar remnants. These are, white dwarf is the name of the object for the lightest stars, such as our sun. That sun will probably become a white dwarf when it dies. Then the more massive stars can form an object called neutron stars. And the most massive stars, when they die, will form a black hole under extreme gravitational collapse. So a black hole is nothing other than a very compact object with a very extreme gravitational field. So much so, as we know in general relativity, any massive object bends space-time around it. The curvature of space-time is gravitation, and that for a black hole is a very extreme one, to the point where even light cannot escape it. So basically, when you take general relativity and solve it exactly for a black hole, and you set the speed of light to be the escape velocity from that black hole, you get this classically, okay? You get this black hole situation classically. And
For a while, people predicted these things, but they did not think that they would actually exist in nature. And then, of course, we have found them, and they do exist in nature. In the wild, we do find black holes. I should also mention that there are some black holes called supermassive black holes, and these are black holes that have eaten material from their surroundings for a long, long time, and over the course of billions of years have become a supermassive black hole. So they are not the ordinary kind of black hole that comes from the death of a star. They've had time to eat a lot. So I call this life hungry black holes because I myself am rather hungry tonight. But we will first read, we will go through the chat, and then I'll probably eat a snack. So we will go back to the reading, but I wanted to define for Nick what a black hole is, okay? So thank you so much, everybody, for joining, and please do like, share, and subscribe. Mods, can you please ask everybody to like and subscribe, share, and all that? Gifts, super chat, things like that are most appreciated. I will get back to the reading. And if you end up falling asleep to this, no worries at all. The video will be posted on the channel under the live tab, and you can always catch it there later on as well, and so on and so forth, okay? All objects have escape speeds. So you might have heard that even the Earth has an escape speed. For example, when we launch a satellite, we have to make sure that it can escape the Earth's gravitational field and get into orbit. What kind of orbit it gets into, of course, also is something we think of. But if it cannot kind of get out of the gravitational field of this planet, then it will not be a satellite in orbit, correct? So pretty much once you have the mass of something, you can determine its escape velocity. So all objects, including black holes, have escape speeds. Earth's escape speed is a mere 11 kilometers per second. So this is a quiz question, guys, for you and everybody. I will ask you again later on, because this is actually a pretty well-known number. So it is simply 11 kilometers per second. So light escapes freely from Earth because light's speed is 3 times 10 to the 8 meters per second. So if you just need to go over 11 kilometers per second, then light would have no issues there. And lots of things have no issues, right? Because we, do this all the time. As would anything else launched faster than 11 kilometers per second. Please tell all those people who like to proclaim what goes up must come down that they're misinformed. That's Neil deGrasse Tyson. I can see how some people might find him a bit condescending. He might be a bit, he might just have a strong opinion. I've been told that he's actually quite a nice guy. Because I met somebody the other day who went to the same elementary school as his kids in New York. So, Albert Einstein's general theory of relativity, published in 1916, provides the insight to understand the bizarre structure of space and time in a high-gravity environment. So one of the nice things about general theory of relativity is that it actually works very nicely and can be solved for black holes and give us the classical picture of black holes before we even found them in nature. Hello, Casual Burritos. Thank you so much for the super chat. Thank you for the $2. If I sleep listening to black holes, will I wake up? You will wake up just fine. I hope so anyways. And thank you, universe, and evil I remove. So this theory of general relativity that was published in 1916 by Einstein gives us the classical picture of black holes, which is quite nice. It's one of the great triumphs of general theory of relativity, okay? So this provides the insight to understand the bizarre structure of space and time in a high gravity environment. Later research by the American physicist John A. Wheeler. So somebody asked about string theory. We will get into string theory in a little bit. In fact, I will look at the chat messages for any questions in a little bit. I will keep on reading for a bit at this time. But general theory of relativity, I will just say quickly, is the basis of superstring theory. Superstring theory is basically taking general theory of relativity and extending to more dimensions and such. And it is trying to basically be this grand unification theory, which also explains and, well, tries to explain quantum mechanics as well. Okay, so I would say the geometry and mathematics of superstring theory is very much based on general theory of relativity. So if you have to learn GR, go to a string theorist. They should do a good job of setting up all the math and whatnot, since they take GR and make it more complicated. But general theory of relativity comes first, okay? General theory of relativity is from 1916, and then Kaluza and Klein, two people, took it and extended it to, I believe, 5 dimensions, and that was in 1919. And then superstring theory was developed much later, 1950s, 1960s, after Einstein's death. But some people think of the father of superstring theory to be the 1919 work of Kaluza Klein, which is still newer than general theory of relativity, and it's really based on GR. Okay, so superstring theory comes later. GR is the more basic classical theory. Okay, so later research by the American physicist and others helped to formulate a vocabulary as well as the mathematical tools to describe and predict what a black hole will do to its surroundings. So this is basically the general theory of relativity is providing the foundational basis for the theory of a black hole. Now, remember that pretty much later on, even later on, we see that there could be some quantum effects that we have to keep in mind when we try to understand everything about a black hole, and that's where we talked about Stephen Hawking's work and whatnot. But keep in mind, about over 100 years ago, like let's say the year is 1916, 1917, and they're doing all this math, and Einstein has come up with general theory of relativity. That is the math that they have to work with, and this was the first sort of classical picture of of black holes. It even predicted black holes. So it's very, very important that we appreciate that black holes classically were theorized and predicted by general theory of relativity, and later on they were found out in nature, in the wild and whatnot. Okay, so thank you for the gifts so much. Thank you. So it's nice that we have this theoretical basis of black holes. Black holes is not just something that was randomly dreamt up or randomly found. People didn't think they would find them for real. They thought that that is probably too extreme of an object to actually exist in nature. But actually, the nice, interesting story, and we talked about it the other day, was that when they discovered neutron stars, which they discovered as pulsars, they actually got hopeful that black holes might be real too, because a neutron star is pretty darned compact as well. So if a neutron star can exist, so can maybe a black hole. And slowly, we have gotten there. And for example, there is a supermassive black hole in the center of our own galaxy, right? And those types of astronomical observational strides have been made later on. But in theory, black holes were a thing over 100 years ago, okay? So that is the impressive thing about general theory of relativity. Among other things, I just want to say general theory of relativity has done many things. This is one of those impressive things. I'm not a theoretical physicist. I'm actually an experimental physicist. Thank you so much for the gifts, guys. Really appreciate you. Timed Out sent a thumbs up. I really appreciate it. Thank you. And FA has sent 100 at one point also. So thank you so much for the gifts and super chats. Of course, keep your questions coming. I will take a look when I'm looking at the comments in a little bit here when I take a break from the reading. And of course, I will prioritize the people who did super chats as far as the questions that you have, okay? So, because it also helps me to find your questions because they stand out a lot better. So, for example, the exact boundary between where light can and cannot escape which also separates what's in the universe and what's forever lost to the black hole, is poetically known as the event horizon. So, by the way, one of the other days somebody asked about the event horizon. So, this is it. This is it. So, this, once again, the boundary between where light can escape and cannot escape of a black hole is also what separates what's in the universe and what's forever lost to the black hole. So once you cross the event horizon of a black hole, it's not coming back. So if you fall into the black hole, we can see you, say we're farther away and we're observing you fall into the black hole. We can see that happening until you cross the event horizon. After you've crossed the event horizon, we cannot see you anymore and we will not know what happened. So some people actually suggest falling into a black hole, if you were interested in such a thing, to pick a certain type of black hole where you won't feel too much pain and you can still see something while you're falling in. And, that way, at least there is that. Because the other people who are seeing you fall in will definitely not be able to get any more information once you've crossed the event horizon, okay? So by convention, the size of black hole is the size of its event horizon. So the event horizon is actually kind of important, one of the important things about a black hole. A black hole, in theory, classically speaking, is actually a pretty simple object because inside of it is something that we don't really can ever know about. Light cannot escape it. There's really no information coming out of the black hole. And so this event horizon, which is the crossing point, after the event horizon, nothing comes out. Well, that is one of the important features of the black hole. So there's a couple things, the event horizon and the black hole's radius, as you will find out. Pretty much with those two things, and the black hole's mass. Black hole's mass, event horizon, black hole's radius, and these are also kind of related to each other. These are pretty much the parameters or the descriptors of a black hole that are the most important, as you will find from this classical treatment of the black holes. And by classical, I mean general theory of relativity. Okay? So, size of the black hole is the size of its event horizon, which is a clean quantity to calculate and to measure. Meanwhile, the stuff within the event horizon has collapsed to an infinitesimal, I said that word weird, infinitesimal point at the black hole's center. So inside the black hole, there is a singularity. Okay, so let me take a little pause here. So keep in mind, by the way, can we get 40 likes? Thank you so much. Keep in mind that in classical physics, in general theory of relativity or classical physics, there are a couple of singularities. These are points where mathematics breaks down and we don't really know how to explain the thing mathematically. And these are sort of flaws of the physics, okay? Flaws of the theory. And there are ways to address it and whatnot, but you'd have to use something else. So in classical physics, there are a couple of singularities. Inside of the black hole is one, and the other one is the Big Bang, okay? The origin of the universe from which things expanded. And inside of a black hole, which actually is the other way around, kind of, things collapsed to a black hole, and that's a singularity. And the origin of the universe from which things expanded to give us the universe of today is also a singularity. So origin of the universe, or the Big Bang, is a singularity. And inside of a black hole is a singularity in classical physics, in general theory of relativity. So that is just something I wanted to mention. It doesn't have to be the end-all, be-all of our understanding of nature, but I just wanted to say that things break down at that point, okay? And also, in the case of a black hole, classically speaking, there's no way to know what is inside the black hole anyways, because even light cannot escape from the inside of the black hole after the event horizon is crossed, and so we would never really know. And the way black holes are defined is that it is an extreme gravitational collapse has happened to make this object so compact that it has sort of this infinite gravitational field. And so pretty much that's what's going on, okay? We don't know, but there's lots of collapse and lots of infinitesimal point happening of the black hole center. So the stuff within the event horizon has collapsed to an infinitesimal point at the black hole's center. Even though that is kind of crazy or weird to think about, that is what we say in classical physics, okay? We take it for the singularity that it is, and we have to kind of give up in that, in the sense of like, what's really in that singularity? We don't know, okay? So black holes are not so much deadly objects as they are deadly regions of space. Let's explore in detail what black holes do to a human body that wanders a little too close. So now he's going to talk about spaghettification, but I wanted to mention to you about the singularity business also, because we sometimes also, often actually, we talk about quantum mechanics as well. And we've talked about superstring theory. And just remember that one of the motivations of superstring theory and of quantum mechanics is to kind of overcome these singularities. Some people don't like that pretty much you have this kind of singularity within a black hole where we're kind of just giving up mathematically. And the same thing goes for the Big Bang, those two, right? So some people don't really like that. And so they would like to work on it and try to do something about it. And those people might end up being people from quantum mechanics or superstring theory, okay? And those topics also we discuss sometimes, okay? So just keep that in mind. Infinite density, yes. Hello, son of Sammy. Thank you for the super chat. Appreciate it. Yes, it's a model. It's a mathematical situation. Correct. Somebody asked about that. Somebody said singularity is a model, though. Yes. I mean, we are modeling the inside of a black hole because we don't know what is inside the black hole, right? So it's definitely a model. It's definitely mathematics. And that mathematics is definitely coming up a bit short for the singularity that exists within the black hole, okay? Now, it might be sufficient for a lot of people who are interested classically only, and it is sufficient to just say that, well, yeah, there is a point of infinite density where just things just kind of break at that point, and that might be a sufficient explanation for a lot of people. But then some people don't like that, okay? Yes, the singularity is a mathematical. Yes, exactly. Some people don't like that you cannot have the full mathematics or the full model of the everything, okay? Yes, so I can see some people making comments about Stephen Hawking. We will get there. Stephen Hawking actually mixed in some of the quantum mechanics properties into his understanding of black hole, and that's what he's known for. So far, we haven't mentioned anything quantum-wise. Okay. Yeah, okay. So, if you stumbled upon a black hole, like I just want to mention that the whole Schwarzschild radius, all of that is the classical approach for the black hole. Quantum stuff we will mention when we get there. If you stumbled upon a black hole and found yourself falling feet first toward its center, then as you got closer, the black hole's force of gravity would grow astronomically. Curiously, you would not feel this force at all because, like anything in free fall, you are weightless. What you do feel, however, is something far more sinister. So falling weightlessly is not the problem. The problem is something else. And you can put in the chat what that thing is. While you fall, the black hole's force of gravity at your 2 feet, because the feet are closer to the black hole's center, accelerates them faster than does the weaker force of gravity at your head. So what is this called, chat? When there's a difference in the force between your feet, when there's a difference in the force on your feet and the force on your head as you're falling into the black hole, what is that called? I just want to see the chat really quickly. Can someone say? Thank you, Big Bad Bear 69 for the gift. Someone, anyone? Tidal forces. Yes. Duke Turner said tidal forces. Yes. Very good job, Duke. So, the free falling where you feel quite weightless, that's not the issue. The issue is that there is a difference between the force that you feel at your feet versus the force that you feel at your head. Because the person will have some height, say 6 foot height or whatever. There's actually a force across your width. There's a difference in the force across your width as well. So there's a couple of tidal forces going on this person. So just, where else do we see tidal forces? Anyone? Do we see any tidal forces here on Earth? What's your dumb question? What do you mean? The ocean! Yes. What was your question? We see tidal forces on the ocean. Daytona Beach? I love it. Exactly, the moon. The moon exerts tidal forces on our ocean. Same thing is happening there. The moon exerts a gravitational force on our oceans, and we see these tides happening. It's interesting, Reese. Shut up. Differential gravity. Oh, I love it. So many of you are answering quite nicely. Oh, I love it. Hello, Thomas. Look at these people. They're answering so nicely. Tidal forces. Yes. Okay, we'll keep going. So, there's a difference in the force between your feet and the force at your head. The difference between the two is known officially as the tidal force, which grows precipitously as you draw nearer to the black hole's center. For Earth and for most cosmic places, the tidal force across the length of your body is minuscule and goes unnoticed. So most of the time, we are experiencing tidal forces, but it doesn't, we don't feel it much. But in your feet first fall toward a black hole, the tidal forces are all you notice. It would be horrible. It would be quite painful there. If you were made of rubber, then you would just stretch in response. But humans are composed of other materials such as bones and muscles and organs. So these organs will not respond well to the tidal forces, unfortunately. Okay? Your body would stay whole until the instant the tidal force exceeded your body's molecular bonds. If the Inquisition had access to black holes, this instead of the rack would surely have become the stretching device of choice. I don't know what that is, but that's what he mentioned also. That's the gory moment when your body snaps into 2 segments, breaking apart at your midsection. Neil deGrasse does like a gory scene, it sounds like. Upon falling further, the difference in gravity continues to grow, and each of your two body segments snaps into two segments. So lots of that happening. Shortly thereafter, those segments each snap into two segments of their own, and so forth, bifurcating your body into an ever increasing number of parts 1, 2, 4, 8, 16. You get it. After you've been ripped into shreds of organic molecules, the molecules themselves begin to feel the continually growing tidal forces. So even the molecules will feel it, guys. I'm so sorry. Eventually, they too snap apart, creating a stream of their constituent atoms. And then, of course, the atoms themselves snap apart, leaving an unrecognizable parade of particles that minutes earlier had been you. But there is more bad news. All parts of your body are moving toward the same spot, the black hole's center. So while you're getting ripped apart head to toe, you will also extrude through the fabric of space and time like toothpaste squeezed through a tube. So falling in, To all the words in the English language that describe ways to die, we added the term spaghettification. So this is called spaghettification of a person. But of course, as you can imagine, if not a person, this analogy with a person is made with a pedagogical motivation because it gets people's attention. But this exact same kind of tidal force business and spaghettification can happen to other objects that might also fall into a black hole. In fact, I mentioned to you about supermassive black holes, which eat a lot. They eat from their surrounding materials to become bigger. And guess what? Depending on the situation, there can be lots of spaghettification of those materials, and it leads to having a lot of acceleration of particles and radiation coming from that. And that is actually why sometimes the surroundings of a supermassive black hole can be quite bright. It's the radiation coming from the material that is infalling. And that is actually how we end up discovering such black holes, not because of the black hole itself, which is dark, and we cannot see it very easily at all, but because of the behavior of its surroundings, and especially the matter that could be falling into it, accelerating like, and creating a lot of radiation. So keep this in mind. The spaghettification example we just now gave has more to do with than just that person falling in. It has to do with explaining how things work for a black hole, okay? As a black hole eats, I did call this live stream episode Hungry Black Hole, which is appropriate. I am hungry, and so are black holes. And especially the supermassive black holes have been historically, of course, very hungry. As a black hole eats, its diameter grows in direct proportion to its mass. So I told you how the black hole's radius, the black hole's event horizon, and its mass are pretty much the most important properties of a black hole, and they're kind of interrelated. As a black hole gets more massive, so does its radius. Okay? So if, for example, a black hole eats enough to triple its mass, then it will have grown 3 times as wide, which is kind of nice. We know there is this classically beautiful relationship between the radius of the black hole and its mass. It comes from the Schwarzschild equations. Schwarzschild is the person who did this work to solve general relativity exactly for black holes. And we get the Schwarzschild radius. We call it after his name. His name is Schwarzschild. So we say, give me the Schwarzschild radius of a black hole, for example, and things like that. And that radius is directly proportional to the mass of the black hole. So actually, there is a very simple relationship between the mass of a black hole and its radius. It's quite nice. And classically speaking, black holes are very beautiful objects because their mathematics, classically, again, is very elegant and not too difficult, okay? So for this reason, black holes in the universe can be almost any size, but not all of them will spaghettify you before you cross the event horizon. Only small black holes will do that. So did you know, I mean, you might know because, we talked about this earlier. we actually went through the math and saw that smaller black holes are more dangerous. So, it really depends on which black hole that you fall into as far as your fate up until you cross the event horizon, okay? So, only small black holes, so the smaller black holes, will spaghettify you more. Why? For a graphic, spectacular death, all that matters is the tidal force. And as a general rule, the tidal force on you is greatest if your size is compared with your distance to the center of the object. In a simple but extreme example, if a 6-foot man, who is not otherwise prone to ripping apart, falls feet first toward a 6-foot black hole, then at the event horizon, his head is twice as far away from the black hole's center as his feet. Here, the difference in the force of gravity from his feet to his head would be very large, so that tidal force is bigger if the black hole is smaller. But if the black hole were 6,000 feet across, then the same man's feet would be only 0.1% closer to the center than his head, and the difference in gravity or the tidal force would be correspondingly small. So if you have to jump into a black hole, please choose a big one. Equivalently, one can ask the simple question, how quickly does the force of gravity change as you draw nearer to an object? The equations of gravity show that gravity changes more and more swiftly as you near the center of an object. Smaller black holes allow you to get much closer to their centers before you enter their event horizons. Right? Because you'll also be much farther away from the center of a bigger black hole than a smaller black hole. So there is that too. So once again, smaller black holes allow you to get much closer to their centers, which is the crazy part, before you enter their event horizons. So the change of gravity over small distances can be devastating to the people falling in. So once again, please pick a bigger black hole if you're gonna be curious. Because if you're outside of a smaller black hole, the danger is much greater. And I don't know, technologically speaking, we could investigate and explore black holes at some point. Your hazard to life would be a lot bigger if you accidentally chose a smaller black hole. Okay? A common variety of black hole contains several times the mass of the sun, but packs it all within an event horizon only about a dozen miles across. So pretty much something that is more than the mass of the sun, several times the mass of the sun, but it has been compressed to being much, much smaller than the sun, just a dozen miles across. That is what I mean by when a star has collapsed so extremely under gravitation to create a compact object, which may be just a dozen miles across, but it has mass of more than the mass of our sun. These are what most astronomers discuss in casual conversations on the subject. So these types of black holes are what he's going to talk about. In a fall toward this beast, your body would begin to break apart within 100 miles of the center. So quite 100 miles is, so that's not good, right? Because you'd feel it. Basically, you might think 100 miles is far enough away, but it's really not. Okay. Another common variety of black hole reaches 1 billion times the mass of the sun and is contained within an event horizon that is nearly the size of the entire solar system. Black holes such as these are what lurk in the centers of the galaxies. So he's mentioned a very big one now. While their total gravity is monstrous, the difference in gravity from your head to your toes near their event horizons is relatively small. So this is the type of gravity, this is the type of black hole, honestly, that I would choose if I had to fall into one, okay? Or get near one. And near is, of course, relative. You should still do the math before you decide. So, indeed, the tidal force can be so weak that you will likely fall through the event horizon in one piece. So, by the way, I have some plots of this. I made a few plots. I'm going to see if I have a picture saved in my phone, but I actually made a few plots of this to show you that actually for a supermassive black hole, the tidal force on you would be sort of like fraction of the force that you feel on Earth, for example. So you wouldn't feel it much. Okay. So indeed, the tidal force can be so weak that you will likely fall through the event horizon in one piece. You just wouldn't ever be able to come back out and tell anybody about your trip. So this is the type of black hole you might want to jump into, because you will be able to kind of maybe see what's inside the black hole if you are so curious. Of course, you cannot tell anyone about it because nothing comes out of the black hole. But if someone got really curious, pick a really big supermassive black hole to jump into. I'm not recommending it, but I'm still recommending, relatively a supermassive black hole will let you pretty much not feel much pain as you're jumping in, and you can maybe even see what's inside, which no one else knows, and you'll make it in there, and bad things won't happen until after. So, but if you're already spaghettifying and feeling so much pain and snapping into two while you're jumping into a smaller black hole, then it serves no purpose. Okay, you won't be able to see anything, and you're already gone before you're inside. So logistically, pick a bigger one. So when you do finally get ripped apart deep within the event horizon, nobody outside the hole will be able to watch. So of course, as soon as you cross the event horizon, nothing is coming out. No information is coming out. So people could be outside waiting, but they will see nothing more. They will just see you entering the event horizon of a supermassive black hole. You will feel something, but not a lot. Maybe depending on the supermassive black hole you picked, it could be a fraction of the force you feel on Earth, right? So really not much. And so as a tidal force, so something there, but not too bad. And you will then pass the event horizon, you'll get in, you'll see whatever there is to see, but you won't be able to communicate that with anybody. But that's why we're having this discussion, is that you might want to good night, Reese. Okay, so as far as I know, as in Neil deGrasse Tyson knows, nobody has ever been eaten by a black hole, but there is compelling evidence to suggest that black holes in the universe routinely dine upon wayward stars and unsuspecting gas clouds. So black holes do eat a lot, depending on which one, of course, but they are known to eat from their surrounding materials. So as a cloud approaches a black hole, it hardly ever falls straight in. Unlike your choreographed feet-first fall, a gas cloud is typically drawn into orbit before it spirals to its destruction. So say if there's a massive gas cloud or a star or something that gets attracted by the black hole, it will not necessarily fall feet first and all cleanly and elegantly like we just discussed in the case of the human being. It will probably orbit and get all kinds of spirally and spaghettified as it falls in. And so it will actually give us quite a display as it's falling in. And that is exactly the case with our supermassive black holes surroundings, as well as what we see with other things like active galactic nuclei and such, okay? So a gas cloud is typically drawn into orbit before it spirals to its destruction. The parts of the cloud that are closer to the black hole will orbit faster than the parts that are farther away. And isn't that So beautiful. We just talked about this with the human being, but it is also true because human being is made of it has mass, and so does the gas cloud, and so does a star. So exactly what we talked about with the human being is going to happen to the gas cloud and the star or whatever the black hole is eating, and the same physics will hold. So I love that, and so hopefully now all of that discussion makes sense. The parts of the cloud that are closer to the black hole will orbit faster than the parts that are farther away. Known as differential rotation, this simple shearing can have extraordinary astrophysical consequences. It's very important, therefore, that we understand them. As the cloud layers spiral closer to the event horizon, they heat up from internal friction to upwards of 1,000,000 degrees, much hotter than any known star. So this eating of a hungry black hole is not lack of drama. There is a lot going on. When it makes gas clouds or stars start to fall into the black hole, there is actually a lot going on. There's a lot of physics that happens there, and sometimes we can see that. The gas glows blue hot as it becomes a copious source of ultraviolet and X-ray energy. What started as an isolated, invisible black hole minding its own business has now become an invisible black hole encircled by a gaseous speedway ablaze with high-energy radiation. So not so invisible anymore in terms of what's going on around it, and this is precisely what gives it away. So oftentimes we see this where around the black hole is all high radiation, like lit up and very bright in all kinds of wavelengths, X-rays, visible, ultraviolet, radio, whatever. And it's because the black hole is eating, and the material it's eating is causing this radiation, okay? Is giving off this radiation as it falls in. It's not falling in invisibly. Since stars are 100% certified balls of gas, they are not immune from the fate that greeted our hapless clouds. If one star in a binary system becomes a black hole, then the black hole does not get to eat until late in the companion star's life, when it swells to become a red giant. So its volume will increase, and what will it do? It will get larger and closer. If the red giant of that binary grows large enough, then it will ultimately get flayed as the black hole peels and eats the star layer by layer. So this is what happens in a toxic connection. One is eating off of the other. But for a star that just happens to wander into the neighborhood, tidal forces will initially stretch it, but eventually differential rotation will shear the star into a friction-heated disk of highly luminous gas. So exactly what happens is a little bit different depending on the case by case, but black hole's gonna eat, okay? And when it does, these types of things can happen. So, how are we doing? How is everybody doing? Sagittarius A star is the supermassive black hole at the center of our galaxy. Alice is here! If we sent a camera in, we could not get the radio signal back from it. Correct, because even remember, we got the black hole equation by setting the escape velocity from the black hole to the speed of light. So even light cannot escape the black hole. A radio signal from a camera is light. Radio waves is just light, right? So even the radio waves from inside the black hole cannot come back out. So Alice is saying, if we sent a camera in, we could not get the radio signal back from it. Exactly. So you could fall in, you can see it if it's a supermassive black hole and you didn't feel much pain, but you cannot tell anybody no information is coming back out, because all of the information would travel no more than speed of light, and that does not escape a black hole. A black hole really, really, really bends space-time to the point of such an extreme bending where even light will be stuck inside. Okay? Because light travels through space-time, right? Light is not just anything different than light is kind of special, but it just follows space-time. It just travels in space-time, and space-time is so extremely curved and bent up by the black hole that even light will be trapped inside. Okay? So no radio waves, no camera, no nothing coming out, okay? Ooh, somebody asked, will it pick up speed? Yes, a lot of the particles. This is a great question somebody asked. I don't know if this is to do with the stuff that we were just talking about. But remember, by the way, guys, okay, people are asking great questions. So did you know how we made the Large Hadron Collider, right? It's a particle accelerator. It's human made. It's in France, Switzerland, whatever, where the bread is good. And what is the big motivation for the particle accelerator? We want to accelerate particles to see the physics of those extreme conditions, and we want to maybe discover some new physics when particles get accelerated a lot and blah, 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 right? Well, guess what? There are some natural particle accelerators in nature, out in the wild, where this is already happening. And this situation that we just talked about, the supermassive black hole or some kind of black hole accreting material in, eating. So a black hole eating is actually one of those environments where particles can also get accelerated a lot, and sometimes accelerated relativistically, and give off synchrotron radiation and such, and that can be one of the sources of all the brightness that we see, all the radiation in different wavelengths that we see from the surroundings of a black hole. So yes, a black hole can very well be a particle accelerator. Isn't that so crazy? I love it. A black hole and other things too. There's gamma ray bursts. They're a transient event in the sky we've talked about as well. Those are also particle accelerators potentially. So basically these types of exotic and honestly not that exotic in the sense that, there is a supermassive black hole even in our own galaxy, right? So, but I still think it's kind of exotic. The more extreme event or object it is, chances are that it is nature's particle accelerator. So yes, things can accelerate. Hi, Duke. Whoever asked about the will it pick up speed, that was your answer to that. I will go through your comments more in a little bit. I love your face and voice. Oh, thank you, Jack. Can you do a super chat? Can you help me meet my super chat goal, guys? That would be most wonderful. And I can also, if you have a question, that would also highlight it so I can see better. Yes, space-time bends towards the singularity. Yes. Yes, gravitational waves, exactly. It does radiate gravitational waves. So by the way, nowadays we do what is called multi-messenger astronomy, where from these types of events or objects, we're not necessarily only trying to get light out of them or, observe in various wavelengths of light. Initially it was maybe just visible light. Then we went into like other wavelengths of light, like gamma rays, X-rays, UV rays, radio waves, etc. And then we also look for particles. Actually, there could be a particle getting spewed out of such a thing, and maybe we pick up on that. And also now gravitational waves. So yes, these types of big gravitational events, like a black hole eating its binary star, for example, like let's say a black hole and a companion star were in a binary, and that black hole eventually, there's basically eventually a merger and some kind of like collapse happening. yes, these are indeed gravitational events that will also release gravitational waves as predicted by general theory of relativity that we also pick up on at this point, as in we are able to measure those types of gravitational waves now as well. Now, depending on the exact merger and the two objects involved and all that stuff, it is a, the gravitational waves could be more or less. And so we might have a sensitivity to only the biggest gravitational events in the universe at this point with our current technology, but people are definitely looking to work on getting them more sensitive. Because remember, this LIGO business, for example, the laser interferometer gravitational observatory, I believe, is the gravitational waves measuring experimental setup that we have in the world, right? There's a couple, and this is the main one. Basically, they have to make very precise measurements, and other things could be noise to that. For example, like an earthquake or little vibrations in the earth could be the noise for that experiment. So you'd have to be sort of like a major, like a really big event for it to qualify as a gravitational waves event, like the real signal, basically. But if you became more and more sensitive, then we could capture gravitational waves that are coming out of even lesser events, for example. Okay, so I would say yes, pretty much any kind of big gravitational event will give off. You're actually, by the way, that process of say even two neutron stars, or it could be two neutron stars, it could be two black holes, it could be a black hole and a star. This process of the dance that the two will do, why do you think they're merging? Why do you think they're merging? Because the event is the system is losing energy in the form of gravitational waves. So actually, say there's two objects in a binary, a neutron star, a black hole, a neutron star, a black hole, and another star. This dance that they do, like they orbit around each other, right? And as they're doing that, they actually get closer and closer. And we measured that a long time ago. So before we could directly measure gravitational waves, that was the measurement of gravitational waves that we did. And that is happening because of a loss of energy by that system in the form of gravitational waves. So absolutely, there it will give off. Now, it's a question of how big is the gravitational waves signal. We might not be sensitive to it, but absolutely these things give off gravitational waves when there's these types of things happening, collapses, mergers, whatever. Space-time entanglement. I think that was your question. Great question. I loved it. That question allowed me to talk about LIGO, which is, of course, our gravitational waves measuring experiment within the last 10 years that we built as a human race and confirmed one of the predictions of general theory of relativity, which is that we should be able to see gravitational waves. Okay? So I'm glad you asked about that. That is a favorite of mine. So yes, gravitational waves for sure. Any other good questions? Alice, what do you think of all this? Did you see any other good questions? We have other scientists in the chat as well. Philip, hello. The Cheap, hello. Spacetime, Ben Depati, Philip, Wilson, Baker. Hello, Queen. It's an honor. Cute earrings, listening. Thank you. Oh, thank you so much. I got this from a trip in West Virginia once. Khalid, hello. I'm wearing my makeup hairband. Hello, Duke Turner. These waves travel at the speed of light. Yes, 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 yes. Gravitational waves travel at the speed of light, which is crazy. Yeah. Yeah, so did you know there was this one so I think there's this like question people ask sometimes, like what if the sun were to disappear? Would we feel it immediately? And we would not. If the sun were to suddenly disappear, it would take 8 minutes, because it takes light 8 minutes to get here from the sun, and the gravitational waves situation would also take 8 minutes, and so we would think that it was fine for 8 minutes, guys. 8 minutes, isn't that so beautiful? Jaren is saying light has particles that are energy. Even energy obeys gravity and time. Yes, exactly. Light travels through space-time just like we do. It is just that the speed of light in vacuum is a constant of nature, but light travels through space-time just like we do, under gravitation, under whatever. Okay, even special theory of relativity is written for inertial systems, so there's no acceleration there. And yeah. Was the Big Bang from a super huge star exploding? So first of all, I will say that I do not know, because we cannot know about the exact beginning of this universe. At t equal to 0 is we don't know, okay? Second of all, I will say that stars as we know it came a lot later than the Big Bang. It wasn't until much, much later that we were starting to make the first clusters, galaxies, and stars. So again, as far as we understand our universe, there is no stars in the beginning. So it would really be some stars that you would be asking about from before this universe. And I don't know about those stars because I only know this universe. The way we describe our physics at this time, t equal to 0 is the beginning of the universe. There is no t equal to -2 or -3. There's no time before that t equal to 0, okay? And the t equal to 0 is the moment of the Big Bang. So I hope that makes sense. Basically, this concept of stars as an object comes much later, after the Big Bang, after the universe goes through stages of evolution. Evolving enough to make stars in the universe comes a lot later. It takes a long time, okay? We have a baby picture of the universe with no galaxies, with no clusters, galaxies, or stars. And so we just know that it was very smooth, and it had some spots of overdensities, which then later on made the first clusters, galaxies, and stars. So there's no stars for a long time, okay? Photons are massless. Very nice. Mickey is saying, I want your baby. Do you mean my cats? Absolutely not. In fact, this is why I get babysitters, so that they are not kidnapped. Goodness gracious me. They are very pretty, but do not try anything. Does light have mass? Is that why light can't escape? No, light does not have mass, but you don't need to have mass in order to follow the curvature of space-time. Does that make sense? Basically, when we are traveling in general theory of relativity under just gravitation, we are actually not accelerating. So gravitation is not a force in general theory of relativity. It is simply the bending of space-time. So you follow a geodesic, or the equivalent of a straight line, which is going to be a bit curvy because general theory of relativity geometry is different than our usual regular life Euclidean geometry. And that line can be followed by light, you, me, Pluto, Uranus, Earth, black hole, anybody under gravitation, okay? So light is traveling according to that. And that is going to be very, very bendy bend bent by the black hole, so much so that light will be trapped inside and it cannot come out. But it is still traveling through space-time. It's just trapped. Okay? Did I say that right, Alice? Hello, Jack. Hello, Joe Dirt. Somebody asked, We're Back asked, is the universe inside a black hole? I don't know. Certain things we really can't know, okay? We don't know if the universe is inside a black hole. Duke has said space itself bends towards the singularity. Space-time, yes, space-time bends towards singularity, correct. In GR, remember, we have 4 dimensions, the 3 spatial dimensions and time. So 4 space-time. All the geometry, everything is done with 4 space-time, okay? Which is bendy bent. Bendy bent, lots and lots bent by gravitation. And in the case of a black hole, very super duper bent. To the point of where light cannot escape, okay? Are black holes evil and stars good? No. Black holes are fine. Smackety-doo, hello. Are you going to do a super chat tonight? You should. When does it become a supernova? So the black hole is a stellar remnant to begin with. A star has died. The most massive stars died to make a black hole. Okay, so a black hole is, in a sense, a dead star. Sometimes it's a supermassive black hole, which would just be a dead star that has eaten a lot. But a black hole is a dead star, okay? It all comes from those clusters, galaxies, and stars in the end, okay? So somebody asked, Joe Dirt has asked, so radiation can escape the black hole. So classically speaking, it cannot. But quantumly speaking, yes. And this is where Stephen Hawking gave us Hawking radiation and a way for black holes to have a temperature, which means that it must be emitting some kind of radiation. Okay, so classical physics-wise, no. Quantum mechanics-wise, yes, where we use the uncertainty principle to give black holes a temperature. Okay. Black holes can actually fluctuate in size. Great question, space-time entanglement. Black holes get bigger when they eat more. And because quantum mechanics-wise, black holes are also, so there's 2 things. Black holes do get bigger when they eat more. Their event horizons get bigger. Their radius gets bigger. But also, because of the thing I just said about the black holes having a temperature, and black holes eventually, in the quantum mechanics way of understanding them, do have radiation. They're also losing mass as well. Jaren asked, why doesn't it become a star again? To qualify as a star, you have to have a nuclear reactor in your belly. So if any object, basically you need to have a certain thermodynamic and certain temperature pressure situations where you would start to do nuclear fusion. Okay, so we are not calling every Tom, Dick, and Harry in this universe a star. For example, we're not a star. Jupiter is not a star. Even though Jupiter radiates some energy, we don't call it a star. To be a star, you have to do nuclear fusion. That's why a black hole is not a star. A black hole is an object, but it's not a star, darling. Okay? Because to be a star, you have to do certain other things, which generally other things don't do. Not star things. Okay. Okay, I'm gonna keep looking at the chat. You guys are too funny. Scott! Scott is here. I'm a physics princess now. Scott is about to do a super chat. Did I say something rude? Yes, so general theory of relativity. So I'm looking at space-time's question now. General theory of relativity is an upgrade of the theory of gravitation. Newton gave us gravitation in his laws of gravity, in his work, and Newtonian gravitation still works as an approximation in many cases, but Einstein's work of theory of general relativity is an upgrade and the more correct theory of gravitation. So he gave us a new theory from which Newtonian equations fall out as an approximation. So, and the way he dealt with gravitation is basically technically it is not a force in general theory of relativity. It is the curvature of space-time and requires a different kind of mathematical treatment and geometry, like I was mentioning with the force space-time, wherein gravitation turns out to be not a force. Okay, so but yes, what we say is that GR, or general relativity, is a upgraded theory and the more correct, up-to-date theory for gravitation. It's been improved by Einstein. Whatever Newton had done, he took that and he came up with something new. And the approach is also quite different, but it's the same topic, which is gravitation. Scott Romer! I'm a princess. I'm a vampire queen. I'm a vampire queen. So last night somebody called me vampire queen, and when Scott Romer does his $49.99 super chat, I say I'm a princess. I'm a princess. Thank you, Scott. Scott, did you miss the beginning of this? We've been talking very delightfully about black holes. Thank you so much, Scott, by the way, as always. We've been talking about black holes. We read a little bit from the book by Neil deGrasse Tyson called Death by Black Holes. It was quite entertaining and fun. People seem to have liked it. So you might want to rewind later on and see the whole thing. Later. For now, stay with us. But I don't know if you joined when we started. I have a... My face looks a bit weird today, doesn't it? It's okay. Is this a book club? It might as well be. This is sort of a booktuber, book club vibe, physics, astronomy, cosmology, discussion, meeting, class, entertainment all in one. Joe said light has to have mass because we can see light. No. Mm-mm. 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 No, 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 no. Light interacts with, light is a form of energy. I mean, honestly, there is mass energy equivalence of special theory of relativity. It's just so the first version of relativity by Einstein, right? The first version of relativity by Einstein was given to us in 1905. It was a big present of Einstein to us and the world. And he gave us special theory of relativity, which is basically the simpler version of relativity, which works only for inertial frames of reference. As in, there's no acceleration allowed in special theory of relativity. And that theory gave us the relative nature of space and time and mass energy equivalence. So if you want to call light a mass, I mean, I guess you could, because mass and energy are equivalent in relativity. But in the sense of, okay, let me put it this way. Sorry, a kitty cat is jumping over my head. Let me put it this way. We talk about light in a particle way and a wave way, right? And sometimes we say certain words like force and particles and photon, and that treatment is more of a particle physics treatment. Whereas the stuff that we're talking about with gravitation, black holes, this type of stuff is more classical physics, which is the general theory of relativity. So in relativity, there is mass energy equivalence, and then there is space-time are relative. Those are the two things that we get. And so if you want to say that light has a mass, you can, but you would be wrong in the realm of particle physics. Because remember, there's also particle physics. And in particle physics, we really care about the properties of particles and such. And over there, the light particle is the photon, which does not have a mass, okay? So there's a couple different paradigms here and a couple different regimes we're working with. And another thing I will say, why I have a high tolerance for certain shenanigans is because both quantum mechanics and general theory of relativity are kind of incomplete in their own ways. But don't say light has a mass, because generally when you say that, when people think of light as photons and such a thing, in that way, it does not have a mass. And because also another thing, remember, in special theory of relativity, light, the speed of light in vacuum is a constant. Nothing can have the speed of light if it has a mass. So in that sense too, it does not have a mass. But in the sense of energy, and in your book, if energy is the same, whatever. Now I'm rambling. But you know what I mean? I hope that makes sense. Light does not have a mass. Okay? Photons don't have mass. Photons move at the speed of light. A thing with the speed of light will not have mass. Neutrinos are very low mass. So people thought they might be massless, and in that case they could travel at the speed of light, but they don't. Only light travels at the speed of light. Only photons travel at the speed of light in vacuum. And so the way in which we generally think of mass, photons don't have that. Okay? Did I say that right, people? What is Alice saying? 9, 10? Thank you guys so much. Scott Romer, thank you once again for the super chat. Who wants to do the next super chat and bring us home? Scott Romer wants someone to match his super chat. Oh, thank you. Scott Romer said, you deserve it. Thank you, Scott. What is Einstein wrong about? A few different things, but also certain things were a little bit he was a bit ahead. We can talk about what he was wrong about. Alice is saying the closest black hole to Earth is said to be Gaia, black hole 1 at about 1600 light years away. And then what did Alice... Hi, Ling Chi. Ling Chi is saying you're so beautiful. Thank you. Nothing I can do about that, darling. Diesel is saying Einstein never proved... Excusez-moi. Don't say that. Actually, his theories were proven to... Okay, yeah. Photons are energy. Show Einstein taught us the most important thing. Keep it. Oh my God. Hello, Nasuna. Hello, MRG. Hello, Johnny. Have you met Neil deGrasse? No, but I met someone the other day who said that she met him in New York. This person is from New York, and they went to the same elementary school as his kids. Light doesn't occupy... Okay. Hello, Marco. Hello, Audulin. Hello, Meep. Oh, Meep asked what's 9 plus 10, and so Alice said 19. Okay. I was thinking that Alice is saying something about some questions answer or whatever. Alice, no. I see. Okay. Hello, Ryan. Thank you. Need PhD to explain to have conversation. Yes, sound about right. Okay, thank you. Thank you. Thank you, user BQ. So Einstein was wrong about a couple of things, but remember that a lot of certain things kind of came after him. So he wouldn't have known about, this certain things in cosmology, expansion of the universe, and the fact that it's speeding up. That wasn't really confirmed until like 1998. So that was long after he was dead. Certain things with superstring theory, even though general theory of relativity is absolutely the foundational basis of string theory, but the fact that superstring theory is trying to explain both GR as well as particle physics and trying to get superstring theory to spit out certain particle physics-y results, Einstein couldn't have done that because those types of particle physics-y things were not known when he was alive. So Einstein was definitely ahead, and he gave us a lot. So if he did a few things wrong, that should also be inspiring to us because it means that even smart people can get things wrong, and it's important to get it going. Get your iteration of the work done, and then the next generation will come and tear it apart and review it and update and upgrade it. And that is fine because a lot of the things, if you're very phenomenally productive as he was, you're going to do a lot of things. Some of it will be right, some of it will be wrong, and you just kind of move on with life as a career scientist. So he was wrong about a few things, and that's okay. Are there interactions between Higgs particles and photons? How would they influence each other? That's a great question. So Higgs is a boson, and so is a photon, is also a boson. And we can talk further about your question in a bit, but that's a great question. Audaloon. Einstein married his cousin, yes, and his second wife was his cousin. I think might have been a first cousin actually. But what can I say? They got along. They got along. Can we get 100 likes, please? He was absolutely a genius, yes. For his time, Einstein was genius because nobody thought that way exactly. Have I been to a planetarium? Yes. I love planetariums. I love getting the planetarium shows. Worked as a curator here in Manhattan, never did any real science. Who? Who are you talking about? Neil deGrasse? You blew my mind when you said Einstein never... Oh, that can't be me. Hello, No Name. Thank you so much for the question. Monday morning quarterback. Oh. I'm looking at the time. He definitely married his cousin and was somehow wholly incapable of managing his sense of direction. Even when living here on campus, even the intelligent mind has to make space, it seems. Hello, CSS. I also don't have a sense of direction, but I didn't marry a cousin. I did not marry a cousin, but I also have no sense of direction. I think when your brain is super developed in one way, it might not be developed in another way. I mean, it's certainly true for me. I don't want to speak for him. His brain is, quite amazing. But like for me, I can remember things well, and I can like remember dates, numbers, names, places, details that happened years and years ago really well. But I have no sense of direction. So Alice has answered your question. No, photons do not interact with the Higgs field, which is why photons, very small packets of energy, are massless. Exactly. So Higgs is a type of boson that we discovered, of course, in 2012. So feels like a really long time ago now, and sometimes a short time ago, but Higgs is the boson, one of the bosons that we discovered more recently. And a photon is also a type of boson. And as Alice pointed out, Higgs helps things have their mass, and photons don't have a mass. So I am not an expert on the Higgs, but I was going to just give you some basic information about all the particles. But I think that is probably something I agree with, which is that Higgs does not interact with the photon. Photons are massless. Every great man can make mistakes. Yes. Certainly very true. I wholeheartedly believe that. I think what's so great is that he was so prolific. Sometimes as a genius, what you are is you're prolific and you do a lot, and you don't worry about being perfect, because actually perfection doesn't lead you to greatness. He is only human. Are you hiring at your job? I can mop the floors. Thank you, Joe Dirt. Oh my gosh. Well, thank you so much. Thank you once again, Scott, for the super chat. Anyone wants to match Scott and his kindness to help meet my goal here for the super chats that I've got going on? A goal. Phil Usher is saying like you much. Thank you, Phil Usher. Please do like, share, and subscribe, my darling. We have many such conversations and discussions, so would love to have you here joining more and more of our lives going forward. It is 3:33 on the clock. Goodness gracious me. Last night we had a long night and we did all kinds of things, eating and discussing and chatting and laughing and joking and dueling each other. But I think tonight's, I'm just fidgeting, don't worry. Go with it. I fidget. Tonight's black holes discussion and all the nice comments that I'm reading from you guys, along with questions and other, discussion on the topic is really, really nice. I must say this is probably one of my more favorite lives. It's been really great to have all of you here. And so please do subscribe so that we can keep having these conversations. Mental is saying, what's your favorite movie? Guess. I'm gonna go get the peanut butter and jelly ingredients and make a sandwich with you guys. You guys guess what my favorite movie about space is. I mean, come on. I think you will guess. Duke Turner is saying, hey, you are almost at 7K subscribers. Not easy to do. Thank you. I know, it's been quite rough. But I'm also quite blown away by all the love and support I have been getting on the channel, on YouTube. So thank you so much, everybody. And thank you, universe. Please, and thank you for all the help, support, protection, blessings, kindness, and guidance. Thank you, God. Why my physics teachers never looked like this? Brandon, oh, well, I have no control over that. Their looks are mine. Sosa is saying, hello, gorgeous. Okay, I've been there. It's awesome. Been where? Oh, Caltech? You should come by the Athenaeum sometime. Who is this? CSS! Oh my gosh! I saw the super chat shift and I was like, who is it? CSS5326 has matched Scott Romer. Jingle bells, jingle all the way. Jingle bells, jingle all the way. What's the next words? Can someone say? Over. Fun. Oh, what fun is to ride a one-horse open sleigh. Is that the words? Sorry, I really suck at Christmas songs. Jingle bells, jingle all the way. Oh, what fun is to ride a one-horse open sleigh. Hey! Thank you, CSS. Dashing through the snow in Caltech CSS. Scott Romer and CSS have matched each other's super chat. Hey! Jingle bells, jingle all the way with no direction sense. And by the way, Caltech is in a desert, right? Am I correct? Pasadena is basically a desert. I have an astrophysicist friend from there who said that it was very desert-like and they don't want to live there anymore. They're here in Boston. We like trees and rain and snow. Not much of that in Caltech, is it? But I would love to visit. Please invite me. Can someone invite me to Caltech? I really want to go now. Pasadena. That is like close to LA, right? I've never been to LA and I have a cousin there. I could even crash with the cousin. I'll come to Caltech. Jingle bells, jingle bells. You should come by. I've been to Berkeley. I gave a talk at Berkeley National Lab on the hill. I remember there was the hill and then more hills and we went all the way up. And I gave a talk at the Berkeley National, in the big auditorium of Berkeley. And they liked it, I think. everybody was very like congratulating and everything, but I have never been to Caltech, which is probably why I've never been to LA. Pretty much for the longest time, the only travel I did was for work. So if my work didn't make me go there, I've probably not been in that area. Okay, Scott Romer, thank you so much. CSS 5326, thank you so very much. Indeed, both of you. Thank you, you've made my day. We just don't use math to do bad stuff. Hello, Nick. Am I a monk? You missed a battle. There was a battle here, Scott. I just saw your comments. There was a battle here between people. Mental Head said, your favorite movie has to be either Interstellar or Armageddon. Pretty much you are very close. Contact, Spaceballs. I think I've seen Spaceballs. It's not that one. If a black hole eats photons, it's eating time as well as gravity and material. Okay. Way to go. Thank you, Scott. Thank you, CSS. Caltech and USSF appreciate positive science reps like you in the world. Thank you. I would love to collaborate. Steve Stanton sent a floating heart at some point. Thank you, Steve, for the gift. Thank you, Steve, for the gift, and thank you, everybody. And thank you, CSS and Scott. Caltech and USSF. Is that University of San Fran? No. What is USSF? San Francisco? University of Southern? No. What could it be? Anyways, Caltech and USSF appreciate positive science reps like you in the world. I would love to collaborate. Caltech, I'm coming. Pay for my flight and I'm there. I have a cousin in LA with a couch. Or I can be in Pasadena in a hotel. I'm happy with anything that has breakfast included. That's pretty much the only meal I need. And I'll bring peanut butter and jelly and Nutella. I wonder the same thing. Isaac Newton is said to have burned a lot of his work about a year or so before he passed away. Really? Oh no. Hi, Obama. New favorite version of Jingle Bells. I like it, yeah. I like it. Jiggle, jiggle, wiggle, wiggle. Oh, yes! Joe is referencing to my jiggle and dimmy methods that I mentioned with exoplanet searches. We talked about exoplanet searches and how there's a couple of methods. One is the jiggle method and the other is the dimmy method. The jiggle is the gravitational method and the dimmy is the transit method. Shotty is adorable. Who's Shotty? Is that me? What does it mean? People call me Shotty here sometimes and I really don't know what it means. I need heating bills paid. I am in Boston. This is no Caltech. It is very cold here, guys. And my heating bills are in the hundreds. Hundreds. Pasadena is very nice. We have a desert lab though. I love visiting the desert. I don't like living there, but I love visiting it. Anytime, come on out. Athenium on me. Wow. Anytime, come on out. Athenium on me. Physics teacher are getting younger. Where are you from? East Coast? Yes, I'm in Boston, East Coast. I'm in Boston, on the East Coast. Let me know if any physicists or scientists visit Boston. We can definitely collaborate here as well, or virtually. My favorite movie is Interstellar. Sector is saying there's a rumor going that my feet stink. That's okay. It could be worse. Thank you guys so much. Can we get 100 likes? I like Star Wars. That's okay. Oh, United Space Force. That's what it is. Hello, Daniel. United States Space Force. I was in the Air Force. Briefly. I mean, depending on how you count my time, for years actually, I was a contractor. And then I was in the government as well. So I'm aware. I don't know why it didn't come to me. I must have been really like deleted that part of my brain for this conversation. But United States Space Force. Are you in that? Blink twice. You don't have to say much. I'm certainly not expecting to hear details. Alice is saying Event Horizon is a great sci-fi horror. Event Horizon. Okay. I'm driving up to Maine in 2 weeks. If you want food, hit me up. Okay. Okay. In Maine? Are you gonna kill me there? I hope not. It's very cold there. New Year's show was great. A short person? How do you guys know that I'm short? $83 so far. Yes, can we get 100 likes? I was not a fighter pilot, but I worked on survivability analyses for pilots, like for our assets and things. So I worked on pure defense, not offense. I like to clarify. It was actually my first job out of grad school. Thank you for the gift. Thank you for the gift. Spiffy Python. Oh, I love Python, the coding language. Oh, you're working up in Maine? Wait, are you in Boston? I forget, Scott. Are you in Boston, Scott? Love the manifestation of defense there. Yeah, I worked in defense. Defensive defense. I worked on survivability, analyses and new technology. I have to pick my words carefully here. I worked on survivability analysis and new technology for the Air Force. Can we convert time into energy? Okay. I actually love the Air Force. People were very friendly there. If you're considering the military, that is the one I recommend. I might be a little biased. A little biased. I mean, I wasn't active duty. I see somebody asking about why didn't you retire? I was a civilian. There are lots of civilians in the Air Force. You don't have to be like an active duty person to work for the Department of Air Force. It's a very big agency, government agency. So lots of like scientist positions and things like that. My position was called research physicist. Like it was very specific to my degree. Like they really care about what your degree is in, and like if you have a PhD, master's, bachelor's, that type of thing. So my branch chief made my title say research physicist. I still kept my like the name card thing from my door. They were nice. Mostly. No, I did not get pregnancy donations tonight because I don't see the pregnant lady in the chat tonight. So last night there was a pregnant lady in the chat and we were supporting her through her nausea. And she was very kind and she donated to the cause here on the channel and supported us. But tonight it's the black holes and our conversation, not pregnancy related. Scientist, yes. Definitely been there, contractor, that is. You're in the Space Force? CSS? Well, you better do more super chats. Your time has come. I better see you in our upcoming live streams doing more super chat. You are blessed with that ability. So I was a contractor at first in the Air Force, but then, let me think, I was with Booz Allen. Hamilton was my company. I was a contractor on site, on the base, at Wright Pat, and then I became a civilian. And so I did that for several years. Yes, FST podcast is saying I worked for the government as well. I'm surprised how many people work in government who are not native born to America. Just proof that we're such a diverse country of immigrants. Yeah, I mean they do a background check, they do your security checks, and you can work for the government. The government is also really big. Like I was talking about how the Department of Air Force is like huge. Like you can go from one position to another, you can change your career, you can change the agency. Like the government is really big. So they need people, and especially they need people that can fill certain roles and like have certain technology requirements and whatnot. So I did. It was my first it was like my first real job, like outside of academia, like not an academic related job, but like a job in a outside of academia. But it felt like a good transition. Like it was, it was kind of weird to learn all new things again. But it kind of worked out. Like I learned a lot in those jobs, and it kind of was nice and interesting that I learned a totally new world than academia. Can we get 100 likes? So I encourage it. If you are looking for something else, like outside of academia, you want to try something out, um, the Air Force is, go for it. Why not? Give it a try. People are pretty happy there, unlike the Navy. I have a few biases, but I've heard that the Air Force people are a lot friendlier than the Navy people. Sorry if I offend anybody. Let the duels begin. Can we get 100 likes? Every Stephen King novel ever takes place in Maine, does it not? Be safe, lol. '86. Oh. So defensive. I do know how to be defensive. It came in handy. Like I defended my PhD and then I went into defense. So. Isn't the Air Force the safest? Look, I'm super biased, so I'm gonna say yes, but I'm not really an expert. Like I haven't directly worked with the Navy. I've just worked with people who've been in the Navy and who've been in the Army and who've been, a lot of contractors have been in active duty before. So I've worked with people who came from Navy, Air Force, Army, everything. And I just noticed that the Air Force people were the coolest and more like fun-loving and outgoing. Space Force is part of the Air Force, right? Or did it branch out? Yes, Air Force acquires the brightest minds and thus, yes, also incur lowest casualty rates as matter of investment to loss concerns. So YouTube content creation, somebody is asking, Duke Turner is asking, what made you decide to start YouTube content creation? So I kind of did content creation for a long time. Like I have a blog. I started my blog back in the day. So I used to be more of a writer. Like I loved writing. I wrote like a few books. I have blog posts. Like I used to just kind of share about school, career, all that stuff. And then it kind of just grew from there. I think I also just started to do YouTube and use it as a platform for science communication and this type of thing. So it kind of took, I would say, I always kind of liked having a creative outlet, and especially like writing and blogs and stuff like that. And then it just kind of naturally transitioned into video content as well. Ask your question, DCX. What did you go to grad school for? Physics. All of my degrees that I finished anyways are in physics. Yes. DCX, what's your question? CSS is saying, first time here, I will definitely be back to hang. Please do. It's been lovely to have you. Please do come back. Subscribe so you can keep coming back to my lives. Would be lovely to keep discussing. I've worked with Booz a ton, solid personnel. They do have some really good people. Some people leave booze after working there for years and years and starting their own companies and things like that. They do have good people. But yeah, Booz Allen was my first non-academic job. Albert, which is also something I blogged about. As in, I didn't blog about the details of my work, but I blogged about my career path. That is really, more what I can talk about is the career path, what sorts of things helped with the job, interview, all that type of, things. Because people in academia can be quite clueless as to like how to get another type of job. At least I was. So I was very passionate about sharing those types of things with early career people. Albert from Southern California. Hello, Albert. What's your question, DCX? Oh, that's right. Scott is in New Jersey, heading up from New Jersey to do work in Maine and New Hampshire. Nothing hard, like physics low, but it pays well. I'm sure there's a lot of high paying jobs in this area, in many areas, but especially Northeast California, all that stuff. So, okay, you're heading up from, I totally forgot. I knew you're from New Jersey, but I forgot. So you're coming from New Jersey, going up to Maine and New Hampshire for work. Okay. What's your field, Scott? Can you tell us? Or is it a secret? If it's a secret, then don't tell us. Then you'd have to really kill me in Maine. But can you tell us what your field is? Jorge, you'll be a great welder. Come to Rhode Island. Oh my gosh. I was talking shit about the Navy, but for very little time. One of the guys that I worked with that sat right next to me, like my first few days at the job, okay? Like I'm in this tiny cubicle on the base. And like this guy's cubicle is right there. Like not even a cubicle, it's like a desk. And this guy's desk is right there. And so I'm happy, friendly, outgoing. I'm like, okay, I have to share the space here with these people. They're all men. And I might as well make friends with my neighbors. So I try to make friends with him. And he was just so like, he was so like, what's the word? Unfriendly or serious or just so like, did not like that I was happy. And guess which part of the military he was from in his previous life. Marines. Not Marines. I was reading a comment. Guess which part he was from. Navy. We'll definitely check out your streams and send those SCs at ya. Oh, thank you. Be well, and I'll send a Janet flight out to ya whenever you want to visit. Well, please do. While it's still cold in Boston, you should have me visit because I know it's warmer there in California. My email is in the description, by the way, if you want to collaborate or have me visit Caltech or the Space Force. So, thank you so much. Thank you for stopping by, CSS. Really appreciate you. And keep coming back. Love to have you here. Okay, Space Force is its own branch now. Okay. So my username is OendryB, My email is in the description. And also I have like other platforms linked in my description. Whichever is easiest to find me, go ahead. Also, just find me here on the live. The live happens quite often. Thank you once again, CSS and Scott. I almost said Space Force. Oh, God. I know, I'm slowly making my way in the chat, guys. Sorry. Do you not like my forehead? Someone's saying something about my forehead. It's where my frontal lobe is, so thank you, God. As technology grows, so we transcend from writing to video chats. Soon you'll be a hologram. How was your room in Antarctica? Oh, that's a great question. It was actually very nice. Scientists are treated very nicely there. I had one of the best rooms. Thank you, universe. I meant for Scott. I was asking about Scott's field. Nobody gets hurt or killed on my travels. Oh, good. Saludos desde Sinaloa. Saludos, hello. So tell us, did you disappear the non-friendly Navy guy? No! Eventually, I started working in a different room because of a project. I know. Finally, I'm at the bottom of the chat. Because of a project, I ended up going to another whole room and building, and I started working in the basement of somewhere else on the same base. And so I didn't see that guy very often anymore, but I think he's kind of stayed in that room initially where we were at. And he continued to be very unfriendly towards whoever else. I just didn't have to see him much. Hello, Puerto Rico. How are you? Do you know the rent situation for a one-bedroom in the Boston area? I do. What do you want to know? I have many comments on the rent here. I'm going to custody court this afternoon with my crazy white ex-husband. That's a biologist. Okay. Well, good luck to you. Hello, Princess Tiara. Thank you so much for your comment. Please do like, share, subscribe. Custody court this afternoon with my crazy white ex-husband. That's a biologist. Wow. Yeah, I mean, Princess, good luck. I hope you have a good lawyer. Which state, may I ask? I know that these types of things can be quite state dependent, county to county and things like that. Not cheap. I believe in God. Okay. What rent question do you have, space-time entanglement? So I have a lot of comments about Boston and renting. If you guys want, I can talk about that sometime. I can say something quickly tonight, but I should probably just expand on that topic because now I'm like very familiar with all of the different neighborhoods of Boston. So it like depends where in Boston. Proper Boston is going to be really expensive. You could get a studio for like thousands, like 3,000, 4,000, or even 5,000 for a studio. I know that there are people in Seaport with a really good view who have like a 2-bed, 2-bath for 5,000. but there's probably a studio somewhere in Boston with, and Seaport is still Boston. You know, like Boston is small, so like it doesn't take much to change the neighborhood. So I know a 2-bed, 2-bath guy who pays 5,000. So that's 2-bed, 2-bath for 5,000. That's not bad. Like that's actually pretty good for Boston. But you could probably get a studio for close to 3,000. And that's probably going to be your cheapest option. But then if you move a little farther away, like still stay within the T options in the neighborhoods that are where the T will take you, you could get more space for about the same amount. So something like 3,000. And a lot of people have roommates. So I have friends who share a 2-bed, 2-bath where each of the bathrooms are really big. And I think each of them pay like 1,700. So that's like a much better number, right? Like I think the total is 3,400 for a 2-bed, 2-bath. And so they each are paying something like 1,700. So things like that. But one bedroom might be less bang for the buck. Thank you, Altitude. You should ask me, Spacetime, you should ask me more specifically like which neighborhood you're looking at, and if you need like recommendations, you could put that in a comment somewhere and I'll see it. Lowell or Watertown is better for you. Well, Lowell is like really far. Don't live in Lowell. That's like north. That's almost New Hampshire. So yeah, maybe I have become a Bostonian at this point. So to me, Lowell is like, that's too far. But there's other places that I can recommend. Quincy, yeah, Southie. Sure, Southie, North Shore. There's so many options. Boston is quite diverse. You should come and stay here. What do you think of the daycare fraud? Oh, yeah. Are you becoming an unfriendly Bostonian girl? I think I'm still pretty friendly, so a lot of people in Boston think that I'm here on vacation. They cannot believe that I am from here, as in I live here. College level, are you here? Oh, thank you, college level Hogwarts. College level is here. Yay. She cute. I'm Michigan, and luckily I found an amazing black female lawyer. Oh, good job. Good job, princess. I'm so happy for you, as in for the purposes of the... Good luck. And I'm so glad you got a good lawyer. I hope you come back tomorrow and tell us what happened. Even if you cannot share a lot of details, I would really be interested to know that everything worked out for you, Princess Tiara. Oh, I didn't see this crazy story. I actually moved to MA for the universal healthcare to have the surgery before we had national universal. Oh, so you're in MA, but you moved to Michigan? Somebody's asking what country I'm from. Why don't you guess? Probably bitter because he's been there so long. You're happy because it's all new to you. Yeah. Yeah, I was happy. But I like being happy. Can we get 100 likes? Jorge. College. Nobody likes Jersey either because of expensive. Oh, you want to be near Harvard? Okay. No evidence that I'm at college level. You're the best. You're so supportive. Thank you. Folks, if you're enjoying the live stream, please show it some love and give it a like. If you want to catch more of, please make sure to subscribe and ring the notification bell. See how nice college level writes? Good job, college. Thought Boston was a country. I'm from Metro Detroit. However, I moved to Massachusetts after I... Oh. I mean, touch wood and evil eye remove. And thank you, God, and thank you, universe. I do like the healthcare a lot in Massachusetts. I don't want to jinx it, but this is actually a great validation for me too, Princess Tiara. I mean, I have health insurance through the state. Like I use Health Connector and whatnot to get my own insurance. Like I get my own, like I pay for my own premiums and things like that. And and I just think the system here is so good. It really is really nice. And I'm glad that you like are agreeing, and I'm not just imagining that it's good here, isn't it? So so you're from Detroit, but do you live in MA now? Are you in the good state now? Currently? And is your legal battle like today, like later this afternoon in Massachusetts? I think you're going to be fine then. I hope it's here. My economics professor let us know that was the only place in the US where everyone has health insurance. Right? It's just like they make it accessible. Like there's a system that actually works to pick out a health insurance and, you know, pay for it or figure out your finances, all that stuff. Like, I just think that I'm just happy. I know Massachusetts housing is expensive, but I like it. I like Boston. I like it. I need the healthcare and the doctors and the vibe here. Thank you, college level Hogwarts. Where did your accent go? Which one? I have so many. I have so many accents, guys. How old you are as you sound like someone with more than a lifetime of experience. I do have a lot of different experiences, yes. Can we get 100 likes? We reached our likes goal. We can definitely go above and beyond our likes goal, and we can also go above and beyond two princesses having a conversation. I know, Princess Tiara and I are both here. College level, Scott did a super chat. Can you have other people do super chat so I can meet my goal, my super chat goal? And then I'll be back doing live again tomorrow night. If you're happy in Boston, stay there. I like it here. I like it here. I don't have family here, and passenger princess. Scott, do you drive? Because I don't have a car. I am actually like truly quite literally a passenger princess these days. I sold my car last year. Are you rich on YouTube yet? I'll let you know in December of this year. I'm a queen and I'm magnificent and I take Ubers. Uber, wait and save. Or I walk. Or I take the bus. Or I take the T. Which is part of the T. I mean, like the train. Which is also part of the T. So, Princess Tiara! Why'd you go back to Michigan? Will be an honor to drive you anywhere. Okay. Can I also bring my 2 other friends? That's another thing I love Boston for. Public transportation. I don't want to jinx it, so thank you, universe, and evil eye remove. But I love that we have public transportation and healthcare, for God's sakes, in Massachusetts. More passengers. Have you been to a Boston hardcore party? What does that mean? Okay, weird. I've been to parties in Boston. I don't know what you mean by hardcore party. Is that a type of party specifically? Oh, and I just remembered, Spacetime was asking about apartments in Cambridge, right? Harvard. So that's Cambridge. So honestly, probably Cambridge, Alston, Somerville, those are your options close to Harvard, okay? You have a strong sense of self. The trolls get confused when you deal with them. Oh, yeah. I do. Heavy metal mosh pit party. Oh, metal party. No. No one ever took me or invited me. Who is the passenger princess? So I am a passenger princess, and there is another princess here. Her name is Princess Tiara. Oh gosh, yeah. Video for New Year's was hilarious. Sorry. I was really struggling, but I went to PF Chang's. I met my friends, and then they zipped me up. College level, some of these comments have so much tea in them, I kind of want to read them. Some of the troll comments are just so entertaining. Alice, you're here. Of course I go hiking. I love New Hampshire for hiking. I love Maine too, actually. I've been to New Hampshire, I've been to Maine. Love both for all kinds of like nature retreat type of thing. I just love doing like a getaway in New Hampshire, Maine. I have not been to Vermont. That is actually a state that's on my list of states I've not been to. And Vermont is like top of the list because it's so close and I've never been yet. You will leave them for you to... Yeah, I mean, if they're repetitively super insulting, then you can delete them. But honestly, some of these crazy ones are so entertaining to read. Leave them. And also the spammy ones you can get rid of because then I can't read the other comments. Oh my gosh, Alice, you're in Colorado. I know you love to hike there. Oh my goodness. White Mountain State Park is beautiful. Same for Vermont. Absolutely. I love the White Mountains. I try to go as much as I can. Vermont, somehow I have not been to yet. I think you can click on the messages. I know. I clicked on a couple and read them. I am a passenger princess by day, vampire queen by night. I am. I am. I am. It's a hike. It's a hike low. It's a hike to Vermont, you mean? Yeah, I mean, at one point I looked up a bus. Like even when I had a car, I would not drive to Vermont because I cannot handle the interstate or the highways. Like the only time recently that I've been on the highway is by mistake because I don't have a sense of direction and I was like mistakenly on the highway and then I end up being very scared. General modus operandi? What do you mean? Are you all up in my business? So, yeah, you should definitely you should take us to Vermont, man. Scott Rumor, because definitely a drive, right? And I could never drive to Vermont. Like, I know for regular people that is not bad, but I could never. So, yeah, I need a driver. I need somebody to give me a ride to Vermont or take a train or a bus, which can be a little hard. But can you ski? No. Not yet. I will certainly try, but not yet. Hello, Carlo V. You need to be a passenger princess. Exactly. I need to be a passenger princess. I get really scared on the interstate, so I cannot handle it. I can't. I wish there were like more trains and stuff that could take us all over New England. I mean, there are, but I wish there was more. I'm extremely scared. It is my biggest fear is to drive on the interstate and do those exits and entries. I cannot. You aren't wrong. The worst part of the East Coast is north of Washington, D.C., all the way. See? That makes me king of the road. I am passenger princess. I am. Self-driving car would just freak me out even more. No. Electric scooter. What's the Jersey Turnpike? What does that mean? How can you talk so smart but can't get over driving a car? I am smart and I'm scared of driving. Any problems? Get over it. You should get over me not being able to get over driving a car. I can drive in the city, like in neighborhoods. I take the back roads. For me, avoid highway is always on. And I do drive. I can drive. It's just I don't prefer to. Of course I leave the New England area on a plane. What are you? A barbarian? I don't drive out of the New England area. I take a plane or a train to New York. Please, please. Or a boat. Honestly, a boat. A boat. Take a boat. Exactly. Exactly. I will take a boat. I will take a plane. I will take a train. But I will not be driving an automobile out of New England, God's sakes. Absolutely not. Absolutamente not. No. 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 It scares me. It scares me. I like driving in the city with a lot of traffic. I can handle that. But I cannot handle the interstate driving. No, 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 no. Without Scott, we're driving you out of Boston. Scott, how old are you? Do you have a driver's license? Okay, you know what? College, can you ask the chat to do likes and subscribes and gifts and super chats? I'll be right back with some bread. I need to make a sandwich. I am driving across the country. Wow. Hi, Sachi Mama. I have never done that. Drive across the country, my goodness. Sachi! Come, Sachi! Come, Sachi! Here you go, Sachi. Sachi's getting a snack too. Should I open a new bread? We finished my loaf of bread last night. Should I open a new one? I'm putting a sweater on too. It's cold. Thank you guys, everybody. You can rewind to the beginning of the live. You can also do a super chat and ask your questions. And we will probably answer them tomorrow. I'll write them down. If I do 51, miles per hour? Oh, you're 51 and driven everywhere. Oh, wow. Thank you, college level. 51 and driven everywhere. You have so much experience. Just made a sandwich, sausage, and peppers. You have a fancy life, don't you? A fancy shancy. Good job. Good job, Scott. Good job. Okay, let me get a plate. Scott, you will see my sandwich won't be as fancy, but it will be pretty good.
Fancy chancy.
Peanut butter, Nutella, apricot, jelly. Did people subscribe? Six, 5, 4, 2. Okay. I have 6542 subscribers. Not 7,000 yet. 6542. 6542. Wow. Okay. Thank you for subscribing.
If you have questions, we will take them and answer in detail tomorrow.
I did cleaning before I started the live, so I'm all good there. But I just now remembered that I started the laundry downstairs and I did not switch it to the dryer yet. So I'm gonna have to go do that before I go to bed. I cannot believe this. The laundry is so far away in this house. I have to go all the way down. All the way down to the laundry. I have to go all the way down to the laundry to switch it. Like I had a pretty productive day. Like I had accomplished things in the afternoon. And hello. Whew. I'm a waiter during my free time. Oh really? Oh wow, look at you, Scott. I'm up so early. I'm such an early bird. I have to go so far. So, okay, so this building, I can't tell you too much, but, you know, this building has many, many floors and many, many stairs. And the laundry is in the basement. It's in the spooky-doo basement. Actually, this basement isn't really not that bad. Like, I kind of like my basement, our basement. I mean, thank you, universe. And evil eye remove. I am happy and grateful for our building and basement. Thank you, God. But the thing about the laundry is that it's cold outside and I have to go out and down into the basement. I completely forgot. Like, I meant to I felt something right there. I meant to switch the laundry to the dryer, but I didn't. I thought at some point I'll take a break and go do that, but I forgot. So now it's still in the no, it is not detached. It's in the basement, but my access to the basement involves having to go outside. It's complicated. It's complicated. It's complicated. It's an old building. So so thank you. So yeah, I started, but I got a lot of things done today, guys. Today Baji had messed up the cat genie again, and I fixed it. I set its setting, a lot of peanut butter, so that I fixed it. I did the trash, I did cleaning, I did litter stuff, and I started laundry. I brought all of the laundry, so much laundry, down to the basement where the laundry is. And I started one load. Just have to switch it to the dryer, which I have not. And some of my neighbors do take out my clothes. They start touching my clothes. Why would you say that? Is that because of the peanut butter? Thank you, Trucker Bee. Thank you, universe, for all the help, support, protection, blessings, kindness, and guidance, especially towards our health and well-being. It is all I ask for is our health and well-being. Please, please. Oh, thanks. Thank you. How could you? How could you? Don't say anything bad to me. Health-wise. Don't do it. Okay. It has jelly, peanut butter, and Nutella. Oh yeah, it's crunchy. Sometimes I get smooth, sometimes I get crunchy. I keep it interesting, guys. I do. It's so good. Can you block the person who's judging my peanut butter? I cannot be perturbed at this time. I cannot. Thank you, universe. Evil eye remove. Don't be jealous of my peanut butter and jelly and Nutella sandwich. I wish you the same and better. You will have more freedom? What do you mean? Hello, Nurul. The kitty cats are upstairs. Hi, Aubrey. I don't know stray kids. I was eating pretty shamelessly last night, but your comment is making me a little shy. I'm living underground, guys. It's so good. It's so good. It's so good. I always make myself 2 sandwiches so I can make myself a 3rd. Listen, I'm purely American now. As in, not really, but I am American because I eat PB&J, where the N is Nutella. I'm not from America, but I am American. I am American because I do PB&J. Do not question my cuisine. Do not. This is from Aldi. Aldi. Aldi's so good. Look at that. True American. I'm a true American. I'm a true American. I'm a true American. Thank you for the gift. Casual burritos. What? Thank you, Nathan. Thank you, Joe. Last bite. Oh my god. Where's Nutella from? Is it from Switzerland? It says made in Canada. Nutella has 2 grams of protein. I'll do wine again sometime. Nutella comes from Italy? Thank you, Sir Slur. I love your science content. I just watched some of your earlier stuff. Thank you. Oh, sorry. You should keep on watching all my stuff. All the lives are posted. Please play them again and again as you sleep, work, eat, drive, train. Tell me not to do another one. please. I have to stop. I need to stop. Don't do it. Okay. You're right. You're right. No. Alice said not to. And she's right. Even the smartest people need a professional sometimes. Professional what? I need many professionals. I need a professional haircut, for example. And a professional driver. Fine, I'll do another. God. All right. This time, I will do more Nutella. Every night in my dreams, I'm thinking about one myself. See, Alice? Alice, you better eat one now. I see you. I feel you. That is how I know you. Go on. Far across the distance and spaces. Time and space, guys. Time and space. Between us. You. What are the next words? Something like that. Have come to show you. Which is a weird sentence. Go on. Near, far, wherever you are, I believe that the heart does go on. Once more, you open the door, and you're here in my heart. And toasted PB&J with banana. Ooh. My heart will go on and on. I'll see y'all tomorrow, guys. Say goodnight. This is my last one, and then I gotta go switch the laundry and go to bed. Good night and sleep tight, everybody. Say good night. Last one. How many did I have? Did I have 2 or 3? Is this my 4th one? God. Is this my 4th one? Good night, Alice. Thank you, guys. Good night, everybody. I'm content. I'm so happy right now. Thank you all so much. Thank you, universe. Thank you, college level. It's been wonderful. Please bring your questions again tomorrow night. I did get chills. I got chills. Please bring your questions. We will have a wonderful discussion again tonight / tomorrow night. Thank you. Good night and sleep tight. Mwah, mwah, mwah. Mwah, mwah, mwah. Thank you, God, and thank you, universe. Probably black holes again, I don't know. Hi, Daisy. I will see you again near and far tomorrow. Bye-bye. I think we have a little bit of black holes discussion left that we can do tomorrow. 11:30 p.m. Bye bye. It's been great. Just great. It's been great. Great. It's been great. It's been great. Bye, guys. Thank you so much.